All right, people, we are running out of toolkits. I think it only goes to 38. I might be wrong. There's like five left after this. Crazy. All right, so same as we talked about, local mins and maxes and all that good stuff, but we're talking about it analytically. So can I just give you an equation like this? And without graphing it, can you find them? Okay, so we're going to talk about it visually or graphically. Um, so anyways, here we go. Let's do it. But can we do it without seeing it is the idea behind analytically, right? So visually, let's say we've got an equation here. Um, Critical values, we're going to talk about that. So critical values are CVs, okay, are numbers, C, in the domain of F such that F prime of C is equal to zero. So they're values where the slope is zero or where F prime of C does not exist. Okay. So there are X values, okay, where the slope is zero. We've seen those before, or where there is no slope. Okay. So I'm going to give you some examples of these. So let's say I started here and I go up and then down like this. But that approaches, let's say, thing, right? So right here, what do we got? We have slope is equal to zero at that point, right? It's a max, a local max. So that is C. I'm going to call this C1. Okay. Um, Here, let's say that it does this for a second. Um, let's do this. I drew one out, something like that. There we go. So there's a whole bunch of C's here. Here's another C right here, C2, where it does not exist, right? At this point right here, what's the slope? It's a teeter-totter, right? Think about balancing your skis on this, could go any direction. Your slope does not exist. So this is another does not exist. Does not exist. Okay, but it is a critical value. This is a critical value. There's the third one. Here's a minimum where slope equals zero at this point. That's a critical value. This is called a corner, right? Again, think about your skis at that point. They can go in any direction. So there is not one defined slope there, right? So this is another critical value because f prime of c does not exist. It's another DNE, right? Here, this is kind of a fun one. At this point, slope is getting smaller and smaller and smaller, and then it starts getting more smaller and smaller, right? Slope can become negative here as well, right? Or sorry, it can become zero. Slope is equal to zero here, even though it doesn't hit a min or a max, right? We know that can happen. So there's another one. So there's six different critical values in this and all a different type, right? A minimum, a maximum, a place where it goes to slope goes to zero but doesn't change. It's still it's a negative slope, then zero slope, then a negative slope. We have a corner and a cusp and a vertical asymptote. So all sorts of different types of places where either the slope equals zero or it does not exist. So all of those can happen, right? So how to find for polynomial functions, it's super easy. Okay, super, super easy. Step number one, or actually the only step, find where f prime of x is equal to zero. Find where the slope of the derivative is, or sorry, find where the derivative equals zero. That's where the slope of the original function is zero, right? So how do we do that? Step one, find f prime of x. Pretty easy here. 2x minus 4. Good. And now we need to find out where this equals 0. 2x minus 4 equals 0. Add 4, divide by 2. X equals 2. So that's my only critical value right there. Okay. Not bad, right? So for rational functions, there's two steps. Start with f of x. Find any value, right? Rational functions. That makes denom of f of x equals 0. Okay, so step number one, what would that be? So step number one, x is equal to 0. That is one critical value. So critical value number one, we got it. It's x equals 0. Step number 2, same as this one. Find where f prime of x is equal to 0. Okay, so we're going to find where f prime of x equals 0. Now this is going to be a special equation, right? This is a quotient, right? So let's go low times the derivative of the high times 2x minus high times derivative of low. So that's just going to be minus x squared plus 9 all over bottom squared. So I think I get x squared 2x squared minus x squared minus 9. So on the top, I'm going to get x squared minus 9, and on the bottom, I get x squared. Okay, so what would make this equal to 0? So when I make this equal to 0, the only thing that would make it equal to 0 is the top has to equal to 0, right? So x squared minus 9 equals 0. That's going to be x is equal to 3 or negative 3. I could factor that, or I could add and then square root both sides, however you want to do that, right? So there's our next critical values. So x equals 3 or negative 3 are also critical values. So for this equation, rational equation or rational function, 0, 3, and negative 3 are all critical values. Cool, cool. All right, here we go. Sorry, I disappeared. I had to kind of plug it in. My battery is low. There it is. All right. So where can global extrema exist graphically? For global, it can be endpoints, endpoints, endpoints. We could have an extreme at an endpoint. All right. We can also have at a cusp or a corner, or we could have at a max, or anytime slope is equal to 0, right? We'll do that. Okay, so anytime slope is equal to 0 of, the slope, tangent line, slope of the tangent line equals 0. So any of those points are where we can end up finding a global max or min. They can appear at any of those. In this case, it looks like this corner and this first derivative equaling 0 are the two that are going to be the max, global max, and global min. Okay. So knowing that, let's do it. Okay, to find global extrema, check critical value and the endpoint. So I need to find all critical values. I need to find all endpoints. So we're using this equation on this. So we're starting at negative 3. So this is endpoint and this is endpoint. So those are two things that I'm going to check to see, because the max can happen at an endpoint. So I'm going to include that in things that I check. I'm also going to find the critical values. So find critical values of f of x. So we're going to go f prime of x equals 3x squared minus 6x minus 24. Is that right? Oh, that's pretty ugly. That's pretty ugly. I'm going to need to factor that, I think, right? I think so. Let's factor out a 3. X squared minus 2x minus 8. I believe that's x minus 4, x plus 2. Okay. So to make this equal to 0, set it equal to 0. X is equal to 4 or negative 2. So those are my critical values. So my critical values are negative 2 and 4. My endpoints are at negative 3 and 6. So I'm going to plug this into the original, plug all of those into the original. So the numbers I'm checking are negative 3, negative 2, 4, and 6. So these are CV plus EPs are here. And then I'm going to do f of x. I'm going to plug it into the function. Okay. So negative 3 into this. I did it already on my calculator, and that was 23. When I plugged negative 2 into this, I got 33. When I plugged 4 into this, I got negative 75. And then when I plugged 6 into this, I got negative 31. Okay. So these are the four options for global max and global min. Do we have a winner? What's the lowest? Yay, global min at x equals 4. Got the global min. Where's the global max? Yay, this is the winner. Global max at x equals negative 2. There we go. So mins and max. So what do? Right? We found the endpoints. We found any critical value. We tested each of those in the original equation to see what the highest and lowest y values were. Okay. If I go to, let me see. Let's see if I can go to desktop here. Oops, how do I do that? If I turn this off, can I go there? Can I go there? Boom. Oh, look, there's our thing. If I go to Desmos, I might have this in here. I think I do. Yeah, here we go. This is it. I just need to turn that one off and turn this one on. This is the graph of what we just did. Okay, so if I zoom in, or let's just change my y-axis and bring that down a little bit. Oh my gosh, come on now. Boom. And then we'll go there. Jeez whiz. Is that enough? Oh, yeah, there we go. There it is. Right. So my high point here, my global max, let's see if I can find it, is at negative 2, 33. That's what we had, right? And then my global minimum, right? The lowest of the low points, the death valley, if you will, is at 4, comma negative 75. So sometimes I can visually see it. If you're wondering, like, what did I do? Look at this. I plugged it in. And then over here, I just have, I don't know, can I zoom out a little bit? Oops, I don't know. I just screwed it all up. There we go. I put into these little brackets that we are in between negative 3 and this should be a 6 over here on the right side. So if you ever want to use Desmos for this and kind of cut off the points, this allows you to kind of cut it off. Anyways, there we go. Seeing it visually after doing it analytically is sometimes reassuring. So, all right, that's it, people. Good work.